Hello, it's Scott Manley here, and today I am looking at Universe Sandbox. Now, a lot of people have asked me about Universe Sandbox because, well, I like spaceship things. I haven't given it a huge amount of praise. I'll explain why, but let's look at it and why you should be interested in it. Universe Sandbox is basically a thing that lets you look at the physical processes of gravitation. It lets you build, a sandbox, for example, this version of the solar system with all the planets orbiting around. Now, you may have seen other ephemeris programs, astronomy programs that let you look at this, let you look at all this stuff. The difference here is that this is actually simulating the processes by using gravity, right? So, for example, this is stepping things forward one day at a time, and that means that it doesn't include things like it doesn't include things like the moon, because if you did that, it would fall apart. If I try to increase this over time, what you'll see is the process will start to accelerate, right? And as it gets longer and longer, it'll start to misbehave, and things will all start to go crazy. You see that things start to get shot off. And as I go faster and faster, things further and further out start to fall apart. And the reason is this is using an integration system called Euler's method. Euler's method is also known by gravity people as crap. It is the most terrible first estimation that people come up with when they don't actually understand physics. So if you have Universe Sandbox, I strongly recommend you go into the simulation options and select accuracy mode, and then switch over to speed accuracy. The reason is this will constrain the speed of the simulation so that it runs as fast as it can, but still maintaining the level of accuracy you are requesting. So anyway, I'm not really here to show you that. What I'm actually most interested in showing you is some stuff about binary systems, right? Binary and trinary star systems, actually, what I want to go back to. I pushed the wrong button. New simulation. There, I'm going to create an empty simulation. So, people have been talking about, ever since I had the space engine up, which let you explore the galaxy, people asked about binary stars and trinary stars and things like that. Now, one way to do binary stars is you have something small like Barnard's star, which is 0.16 solar masses, and then it can orbit the sun. And if we start that running, you'll see, if I just come away, this thing should be orbiting, but maybe it's not. Yes, there it is. And I go, because I haven't switched it into speed accuracy. There we go, and then press play. There! So now, those two stars are orbiting each other. Now, one thing to notice is if I zoom in and look at the sun is not actually still, right? If you look at Kerbal Space Program, the star is fixed in the middle of the universe. But in reality, that's not the case. If I'm just going to balance everything, and we make this a binary orbit, add the Barycenter. Actually, didn't need to make a binary orbit, but if you see this thing here, it's added the Barycenter. This is a center of mass of the system, and you can see that Barnard's star is about 1/6 of the mass of the sun, so the Barycenter is much closer to the sun. So if I pause this and take this, raise the mass up to 1 sun, and then I'll select them both again and make binary orbit just to make sure the velocities are fixed, and we go, oh, it crashed. Isn't that great? Yes. This is a common problem. Let's put two suns next to each other, right? Instead, two things of exactly the same mass. Select them, make binary orbit, add the Barycenter. Now you see the Barycenter this time is right in the middle. And just click on this and just check. Yeah, still in accuracy mode. So if I select the Barycenter and press play, you see that they're just zipping around like that. And you'll find lots of binary stars that have very close masses. If I clear these out and delete everything, let's create... Now, what am I looking for? I'm looking for Alpha Centauri A, which is 1.1 solar masses, right? Oh, they crashed into each other. That was great. I didn't mean to do that. No. Delete. I'm terrible at this. Pardon me. I don't use this nearly as much as I would use, my own integration software. So Alpha Centauri B is 0.9. So this is basically, this one is 10% heavier than the Sun. This is 10% lighter. So if we got to do this special thing to make them a binary orbit, put the Barycenter in. There's a specific reason I'll show you this in a minute. But if I now press play, we've balanced everything. Oh. Where the deuce is this? I'm coordinated in an absolute space. I'm going to need to pause this again to find... give me the Barycenter. Thank you. Okay. This is supposed to have a good UI, and it does have a fantastic UI compared to the high quality simulations I would write. Mine would be incredibly accurate, but would have a terrible user interface. So again, you can see these things orbiting each other like that, right? We balance everything out. We should zero velocities and they both fall into each other. Ha 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 ha. So, the next question is, if you have a binary system, where do the planets exist? Well, let's delete this again. And we'll go back in and we'll create Alpha Centauri A. And we'll pause the darn thing because we don't want it running off. Alpha Centauri A, Alpha Centauri B. And how far apart have we placed these? I haven't actually looked. I'm going to add the Barycenter because that's important. And make binary orbit, balance these. And then we can play this. Okay, and again, I need to find the Barycenter, damn it. Okay, that's what we're following. Now, where could the planets exist? Well, let's drop some imaginary planets in here. Alright, let's drop the Earth. Where could we put it? Well, here's one of the problems is it's going to want to orbit one star or the other, right? So if we started orbiting Alpha Centauri A, let's see what happens if we do that there. Let's play. Oh, there. Now, first thing to notice, as I've started this off, the simulation now with the speed accuracy setting is now running a whole lot more slowly. And the reason is, this Earth-like planet is caught in the gravity field and is experiencing a much higher forces, right? So that means the simulation has to run at much smaller steps because every step is has more changes in it. So this one little Earth here is constraining the speed of the whole simulation. So you can actually have, and that is a really bad example, but you can actually have stable orbits around these things, around individual stars. But if you go a little further out, and I'll go out about here, let's see where that one goes. We'll take off this little one so that we can slow down the simulation. That it doesn't slow down the simulation anymore. There we go. This one decides to fly off here. Is it going to come back? It is going to come back, hopefully. And yeah, it's just slowing down ever so much, and then gravity is starting to pull it back. Now, the thing about binary systems is they have angular momentum, and they transfer it back and forth between the entities in it. So watch what happens here. Ah, crap. This one is now getting slowed down. There we go. And it gets obliterated. So there exists, very close to these, you can produce nice stable orbits. If we zoom in, you can see somewhat stable orbits there, right? As we go further out, the orbits become more eccentric. And, when you do it there, let's see, does it actually get out? No, it doesn't. But we can do this one here. And this one will probably escape Alpha Centauri B. Let's delete this. See where it sits. Maybe not. Actually, what I should do I have an option to plot hill sphere? Hill spheres. Hill spheres are technically the region within which you can have stable orbits. If you extend beyond it, your orbit cannot be stable. I also see it says Lagrange points. Unfortunately, none of these Lagrange points make any sense because the mass ratio of Alpha Centauri A and B is too low to make the Lagrange points work. Your mass ratio has to be much higher. It has to be something like 42 to 1 or something like that. I don't remember. Let's just click this one and take it out of there. Come on, delete. There, take that. Ah, my God, it's gone away from the Barycenter. My point here is that if you want stable orbits, they have to be very close to these stars. If they're too far out, then they see the influence of the other one and they will fall into unstable orbits. Another place you can do it, now if I pause the simulation here, is we can see this. If you put it on this orbit here, it's going to put it on... It's going to try and put it on an orbit around this one, but it'll then add the orbital velocity. So this one wants to shoot off to infinity. So what I have to do is select this and then select the Barycenter. That's why I really made the Barycenter. And then say make binary orbit. And that way it'll orbit this center of mass as if it were a single star that massed the same as these two. So what you're going to see now is something that's just a little too close in to be totally stable. And you see it already get a kick from it. Now, is this going to come back? It may or may not come back. It is going to come back eventually. Let's while this one's spinning out here, let's stick another Earth slightly further out. And I should pause it again. Oh man, I hate this. I hate this UI. It's really not the most comfortable thing in the world. Make binary orbit. And then run again. Okay. So we're zooming in. I'll just close this. So this Earth, a little further out, is a little more stable. Watch, this one's going to fly in really close and we'll see what happens. Does it get a kick or does it get slowed down? Well, you see that its orbit has changed quite significantly. This one is continually threatening to do something. Let's create another one even closer in. Yeah, it's all a question of finding the one that is in an orbit that is interesting. And interesting is a questionable, well, it's a rather subjective term, let's say. Yeah, here's Earth 9. Never mind Earth 2. This is Earth 9. And you see, we're trying to set it to orbit as if there was a single mass in the center, but it's not. There's two masses, and they act there. You see, this one, Earth, had its orbit changed yet again. So, Earth 8 seems relatively stable. I mean, it's not. If you run this for any length of time, it will probably get its orbit changed a lot. If you go further out, and you have to, again, pause it, if you drop these in, because it's going to want to create an orbit around one of the stars rather than around the Barycenter. And I'm sure there's a way to fix that, but darned if I know. Make binary orbit. And so this one will be much more stable. So the idea is that when you've got a binary system, you've got stable orbits very close around these objects, and once you get too far away, you get chaotic orbits which can't last for a long time. And then as you go further and further out, eventually you go far enough out that you can treat these two objects like a point mass and it's stable again, right? So this is a simple binary system. So how do you have a trinary system? Well, there's two ways you can have a trinary system. I mean, there's multiple ways, but if you want to have another Alpha Centauri B, it has to be way out here where it's stable, right? So let's stick one out here and drop it. And again, we have to do this binary orbit thing. We've got to pause. Oh, I didn't pause it even. Hold control and make a binary orbit. So now I want to zoom out. So these ones are still orbiting. Earth 8's orbiting there. And Alpha Centauri B11 is just zipping around there. So that would be a triple system, right? You have two objects in a tight binary and the third object orbiting way out here. on its own. And this one, it has much larger area for having planets. But the more objects you have, the more crazy things get. This is what you call a hierarchy, right? You have this little cluster here can be treated like a single object when you get far enough away. So this object can orbit it. So you can imagine it as this object orbiting a 2 solar mass body, which is in fact these 2 individual objects orbiting. And that's how, multiple star systems end up being in reality. Now, of course, you can take this, and if we pause it, we can make this a double star, right? If we go in and zoom in close enough, and this might mess things up. I'm entirely positive that this will mess things up. Let's try, what can we find here? Eta Carinae. No, we don't want Eta Carinae. It's Barnard star. We could put Barnard star in. I guess we could. Oh yeah, we could put the sun in there. Let's put the sun close in here. And again, we need to select both of these tools and make binary orbit. Add Barycenter, and hopefully this will now run when it's going. Or maybe they'll fall into each other. Who knows? We should probably nuke these Earths since they're not that interesting. Delete. Delete. Deleted. Wait a second. What happened? Did I accidentally delete one of my stars? What the deuce? Did I kill... This is hopeless. I tell you, this user interface not my favorite by any means. Okay. Let's zoom in here. Look, the Barycenter is there. And we have a Barycenter just floating around in the middle of nowhere. That's totally useless. Let's kill Earth B. Right, let's try creating this other binary out here again. So we'll create sun, drag, make binary orbit, add Barycenter. Now what we probably want to do is select this Barycenter and maybe make binary orbit. Let's see how that works. Let's see if that actually works to create what we need. I'm not sure this is actually working. These guys are orbiting, right? Yeah, they're orbiting each other and they're orbiting this central star, but they're taking a really long time to go around. So that's one way you can have a quaternary system, as they say. You can have these points. But then, here's the thing. If you were to add a 5th star, well, this point and this point can be treated as, two masses. So these are orbiting each other. So the next place you can add a star is like way out the edge, here, right? You would have to be even further about because these two clusters can be treated like individual stars that are messing around with each other. So you have to go in actually. And this is where this is where I much prefer actual equations rather than a UI to do this, because god, okay, look, I can't make a Barycenter. Maybe if I just drag out, I can make a Barycenter for both. Oh, there. So we'll add the Barycenter and we'll select the sun and we'll say make binary orbit, and hopefully, okay, these things now are orbiting. And this one out here is orbiting on its own. And, I can adjust, if I want things to go faster, I can adjust this speed accuracy down. Obviously, I get lower accuracy. But you can see that it... See, the way that Universe Sandbox projects its orbits is based on it orbiting one object. And it never quite figures things out properly. This is why you get all this garbage on the screen. As I said, I'm not the greatest fan of Universe Sandbox. So, okay, that's basically a hierarchical system. You have like a hierarchy of these two close binaries and these two close binaries, and then further out you have to have another one. So you can kind of draw a tree, and you can only have 2 stars orbiting each other stably. As soon as you had the third one, it has to be really far away for it to matter, or really close in. So let's nuke all this. There's one other way you can have like triple systems. If you have something like I don't know, this 100 mass star. Did I put that in there? You know what? I'm going to stop. You know, actually, I'm going to go and create a new simulation, create an empty simulation, because I don't need all this garbage. So yeah, if you have a dominant star, say something like Deneb, which is 22 solar masses, it's a blue giant, right? As I pointed out in my in the solar video, as stars get more massive, they turn blue, and people seem to be confused by this. Anyway, because it's so massive, it can have small stars orbiting it, like a solar system. For example, we can put in Barnard's star. What else do we have? We don't have... we have a seafood variable. No, we don't have that. Let's look for the little ones. Where is... they're all like super massive, heavy things. Canis Majoris, Polaris... Where is Wolf 3? Ah, there, Wolf 359. So we can have Barnard Star and Wolf 359 orbiting Deneb, just like planets, and they'll work. You know, if we run this and we set our speed accuracy option, you see they'll orbit just fine. So that's another way you can have like a triple star system. Essentially, you still have a big dominant, you have a dominant mass. And the fact that so you're not having a Barycenter that is largely offset. But if you have, solar mass things or if you have things that are very much the same mass, then you generally only have like binary pairs set up in a hierarchy. As it turns out, however, if you have three masses or more, but if you have three masses that are exactly the same, there is a very fancy orbit that you can come up with that is absolutely stable. So yeah, I couldn't do this in Universe Sandbox because it didn't really offer me enough ways to mess around with it, let's say. I couldn't figure out the interface, so I just went back to an old thing I made a while back. This is what's called a three-body Braid orbit, and it entirely relies on all three masses being identical. If they're not identical, this thing breaks down very, very quickly. But if you've got three masses that are completely identical, then this is actually stable and you can perturb it a little and it will self-correct. It's kind of a cool discovery that this actually exists and is stable. It's in fact, it's another solution to the three-body problem that is completely solvable, apparently. So yeah, I hope you guys learned something there, because I see a lot of random idle speculation. Maybe you'll go out and get a Universe Sandbox. It is on Steam. As I said, make sure you put it into accurate mode and use the time accuracy sliders. But I will be back with more Kerbal Space Program soon. But until then, I'm Scott Manley. Fly safe.